So everybody should remember this question that we started yesterday. This question was a question about heating oil and the sales of heating oil over the course of a year. And of course, it fluctuates depending on the season. And what we were asking is, when are the sales less than 4,000? I gave you a graphical representation of it, right? This is not the way that you're supposed to answer it, but I want you to just see for yourself what it kind of looks like on a graph, which is what you're looking at right now. This red line represents the function, the 1600 cosine, etc., etc. That's the function. The blue line represents the $4,000 level of sales. So clearly, the sales are way above 4,000 for a part of the year. It dips down, usually in the warmer months, then it rises again. And what we said is, why don't we figure out where the equation is equal to 4,000? So we did that. We set the equation equal to 4,000. So a quick recap of the stuff we did yesterday. And then we did all the stuff you'd have to do to solve for the x, which is to bring the 5100 over, and we divided by 1600, and then we took the cosine to the minus 1 of this. This is negative, but we don't take the cosine of a negative. That's the way I do it. What we do is we figure out what the cosine to the minus 1 of this ratio is. Works out to be 0.81. Then we, using the fact that it's negative, figure out what quadrants we're putting that in. So just a quick recap of the stuff we did yesterday. For cosine, that would be the second and the third quadrant. So we went through the calculation for the second quadrant, right? And that would be the pi minus 0.81. And that was the 2.33 and the 3. Well, we haven't done it for the 3.95 yet. We did it for the 2.33. And so here is the calculation. Works out to be 4.95. Well, that's good because that certainly looks like this value right here, which is approximately equal to 5. So really all we need to do now is just finish this up by carrying out the calculation again, but this time in the third quadrant. So we did the pi minus 0.81. We're going to do the pi plus 0.81, which we say is 3.95. So we're going to do the same calculation all over again. So we're still going to have the pi over 6. Let me use the same color I used the last time, which is red. So we're still going to have the pi over 6 x minus pi over 12. But now it's going to be equal to the 3.95. Right? And so I'm going to be asking one of you to help me out here. We know we have to, first of all, add the pi over 12 to this 3.95. So pi over 6 x is equal to 3.95 plus pi over 12. And then we have to take this result, and we're going to multiply that by the reciprocal of pi over 6. So x should be equal to the 3.95 plus pi over 12 multiplied by 6 over pi. Okay, so why don't I get somebody in the room to help? Alexa, can you help me out with that, please? Could you put that? Alexa, are you there? Let's just make sure Alexa is there first. Perfect. Alexa, could you help us out with your calculator? Please make sure it's in radians. Actually, it actually doesn't matter for this because we've already done the cosine of the cosine to the minus 1. But could you go ahead and calculate what 3.95 plus pi over 12 in brackets multiplied by 6 over pi works out to be, please? Okay. So everybody else should be doing this for themselves because you obviously want to make sure that if Alexa, and Alexa generally does well, but just in case she makes a mistake, that you can help her out. So please, everybody work this out for themselves. Make sure you know how to do this for yourselves. Okay, Alexa, whenever you're ready, please put your answer in the chat, or you can just unmute and say what you got. Either one. And of course, we should have units on this. I didn't have units the first time. This is actually the month of the year. So it's 4.95 months is what this really is, right? The x-axis that we're measuring in is in months, all right? So that's like just before the 5th month starts, just before May starts. We're somewhere towards the end of April when this 4.95 comes around. Alexa, please go ahead. Points. Oh, is that the final answer or is that the 3.95 plus the pi? You figured it out. Okay, perfect. So 8.04 sounds about right to me. And that, of course, is months as well. And if we go back to the graph, and hopefully everybody else And a lot of people are chiming in and saying yes to that. And when we look at the graph, which I'm going to go back and look at right now, I would say that you're kind of in the same place as the graph, right? You're somewhere, you've started off month 8, so it's in August sometime, and a little bit into month 8. 8.04 means you're into month 8. So really, we can roughly say that it has something to do with month 5 and month 8. But here's the thing that we really need to be sure of. Do we know whether it's before? No, we have a picture in front of us that tells us that it's probably going to be between these 2 months that we are below the $4,000 line, right? What if we didn't have the picture? How would we know? We know when it's equal to 4,000. That's what we just solved. We just solved the equation when it's equal to 4,000. But how do we know? Let me just erase this here for a second. How do we know that it's not maybe this part of the graph that's below 4,000 and maybe this part over here? Is there a test that we can use to figure that out, right? Because all we have are 2 spots where it's equal to 4,000. But is it that if we go to the left of that value, we would be below 4,000, or to the right of the other value, we'll be below 4,000? Can anybody suggest something that we've learned that maybe could help us to figure out whether we're below 4,000 between those two values, right? Plug the value of x in the equation. I was thinking of something else, because remember, we need to be between the two values. Set it to be less than 4,000. Okay, let's do it this way. Here, remember we did interval analysis? Remember that thing where we set up those tables? What we're doing right now, we're setting the equation equal to 4,000. So we know when it is exactly 4,000. Well, what if we said, okay, for us to know whether it is to the left and the right of the 2 spots where it's at 4,000, or whether it is between these two that you're at 4,000, well, the easy thing to do is pick a number between 5 and 8. There are not that many numbers. So let's take 6 or 7. In fact, those are the really only 2 numbers. Put those figures into the function and see if you're getting a number less than 4,000, right? So let me give you an example. Let's say that for this, we're going to find the f of, let's say 6, because 6 is obviously between 5 and 8. So we just plug that into the function, and if I could just remember what the function was, 1600 cosine pi over 6 times 6 minus pi over 12, close bracket, plus 5100. The answer that we get should be less than 4,000. Okay? So I'm going to be asking one of you to do that for me right now. All right? Let's see. Daniel, could you get your calculator out for us, please? Daniel, are you there? Is Daniel there? Okay, Daniel, here's our function. Let me go up and show you the function again. All right, this is just to assure us that we're in the right zone. Is it less than here and greater than here, or is it between these two values? Let's take a value that's in between where it's equal to 4,000. So what I want you to do for me, please, Daniel, is to calculate this function that we're looking at here. This function that we're looking at here when the x value is 6. All right, so go ahead and do that first right now. So 1600, okay, now you need to be sure that your calculator is in radians, because you're going to use a cosine key. So plug in 6 for the value of x, and you make sure, tell us what that number is, by the way. That number is hopefully going to be less than 4,000, which means that we're in the right interval, the interval that's between the numbers and not to the left or to the right of those numbers. Daniel, are we clear on what we're asking you to do? Daniel, are we clear on what we're asking you to do? Okay. I'm asking you, the number that we're picking is 6. I'm trying to find the f of 6 for the function that we started off with, which is this function right here. Okay. Oh, that's kind of messed up. Let me try that again. Which is this function right here. I want you to put the value of 6 into that function. Why do we pick 6? Okay, well, we could pick 7, Hussein. As long as it's between the 2 values that we got. We got 2 values, Hussein. That's a good question. We got 2 values of x. We got 4.95 and we got 8.04. So we're just trying to pick a number that's in between those two. So we're using 6. We could have used 7. All right. But it's a limited number of numbers, obviously. We can't use 1, 2, 3, or 4. We can't use 9, 10, 11, or 12 because those are on the other side of the numbers that we're using. Okay, Daniel, are we clear on what I'm asking you to do? Now, I'll go back up and show you the function again. Okay. Okay, please go ahead and tell us what the result of that calculation is. So 1600, the cosine of pi over 6, basically times 6, minus pi over 12, plus 5100. Okay? So we'll give you a couple of seconds to get that done. Everybody else should be doing this for themselves. You know, I always encourage you to make sure that you're using your own calculator to do the exact same thing I'm asking somebody to do so that they know how to do this on their own. So while I'm waiting on Daniel, I still would like everybody to have their own answer. For one thing, Daniel may not get it right. I've got stuff wrong and he may get it wrong. And then we can always make sure that he's right. Okay, Daniel, so over to you when you're ready, please. So you're just going to type that function into your calculator, replace the x with a 6, and let's see what number you get. We're hoping, we're crossing our fingers that that number is less than 4,000, which would confirm that we should be between the 5 and the 8. Okay, that's the whole point of us checking that. You got 3,554.52. All right, can we, okay, Donna is giving you the thumbs up on that. And Brannon and a whole, okay, so I got a whole bunch of people who are agreeing. So f of 6 turns out to be, I'm just going to write that down here. Shiabun, everybody is on your page here. 3,554.52. Great stuff, Daniel. Thank you very much. And so you can clearly see that this number is in fact satisfying the inequality that we're trying to solve. The inequality is, where are you going to be less than 4,000? Well, when you're at 6, which is what the number that we just chose, this number right here, clearly your answer is somewhere less than 4. You can cut the graph and you can kind of tell that it's somewhere about 3,500 as well. Okay? All right, so I'm going to move on from this. Right, I'm going to move on to something called curve fitting. And you've kind of done this stuff before, but not necessarily with trig functions. I'm going to walk you through how that works with trig functions. So let's get to that right here. Actually, let me take, which one should I take? I'll take this one. We'll save her. Okay. So, the moon is illuminated in differing amounts. This is something you already know, depending on its relative position to the Earth and the Sun. And this table shows you the percent illumination on different days. So it's 0% illuminated on day 1, then it's 10%, and so on and so forth. You can read the table for yourself. Find an equation for the data. Now, obviously, after you go through this cycle, it's going to do the same thing all over again, right? This cycle is how long? There are some things that we're going to try to answer as we go through this, because we're going to try to find a sine and a cosine equation that models this data. Let me just warn you about something. As we try to put this together, our graph, our model may not be perfect. Your homework question, I actually tried homework question myself, and there is no perfect model that is going to connect every single dot, right? In the real world, when you go and collect data and try to model what Mother Nature presents to you, your models will never ever be 100% accurate, right? Whether because you've collected data with errors in it, or because, you know, when you're trying to predict, for instance, the weather, you know, things aren't exactly the way you expect them to turn out because of various things. So that's how models are. Models are flawed, and they're very limited in how consistent they are, right? I just want to make sure we put that out there. Okay, so here's where I'm going to be asking you to switch over to Desmos. You see the data that's on your screen, right? This data up here, we're going to be using this data. Although we are actually, you know what? Let's before we go to Desmos, right? Let's try to work this one out before we do Desmos, and then for the especially for the second one, we'll use Desmos some more because this one already has a graph associated with it, right? So we gave you a graph that shows you how this illumination changes over the period that's shown by the table. So on day 1, you're at 0. By the time you get to day 29, you're back to 0. And these numbers represent where you are on different days within the month. Okay, so could we figure out that? And it's good that we have the graph to help us out. But if we just had the table, and you're going to end up with just the table, are you able to unsubmit an assignment? Because I handed in today's homework already, Kelvin says. I can delete it and you can hand it in again. Okay, so I can do that if that helps you out. Right? If I guess you want to change something, I mean, it's okay if it's okay, if what you turn in is okay, then I'm fine with that. Right? But I can delete it if that's what you want to do. All right. Okay. So bear in mind that even though we have the graph here, we should be able to come up with an equation based solely on the data. So here are some things that we're going to be looking for from this data as we try to put this together. We're going to be trying to look for things like the amplitude. Is there a way? I'll write down A for amplitude. Is there a way for us to come up with the amplitude by just looking at the table itself? He's on his phone. Leanne, Mr. Kamak, my Chromebook wasn't working. I was here, Leanne says, but you're on your phone. Okay. I'll quickly put you in. All right. So is there a way for us to come up with the value of A based on the values in that table? Is there a formula that tells us how to find the A, the amplitude? Does anybody remember what that formula is saying? Max minus min divided by 2. Perfect. So why don't we go ahead and put that in then? Right? So you're saying your max in this case, well, we know what our max is, right? The maximum y value is the y values that we're looking at, by the way. So if you have a table of values, the x's would be the days, and the percentages would be the y's, and we're focusing on the y values now. So if I have the y values, what's my max value? What's my min value here? Not just the same, everybody else, right? What's my max? What's my min here? Focus on the y's. Focus on that second row. So 100 and 0. Thank you very much, Quinn. So I'm going to have 100 minus 0 divided by 2, which is obviously 50. Okay? How about the last value? Now remember that the last value is the vertical displacement. So that's your center line. I don't have the general format for the equation here, but we'll call it the, what do we call it? We call it the C value. For no particular reason, we call it the C value, right? How do we get the, thank you, Roma. Thank you, Quinn. How do we get the vertical translation, the center line of the function? So that number on the end of the sine function. How do we get that number again? The vertical translation or the center line of the function? Does anybody remember how we get that center line again? It's max plus min divided by 2. Well done, Hussein. Well done, Kelvin. So in that case, it'll be 100 plus 0 divided by 2, which in this case is also 50. Okay. I'm going to get back to what this stuff on top here means. This was covered in one of those classes that we did last week. Some people took off for the second period, and I wasn't able to record. Well, I did record it, but I had some issues with it. But we'll talk about this again. This thing about turning from a sine to a cosine and from a cosine to a sine. We'll talk about that in a little while again. So far we have, I'll just move this down. So far we have the A, so far we have the C. How about the period of the function? Let's go back to the function again and see if we can figure out the period. How long is it taking, the length of one cycle, good. How long is it taking for us to complete the cycle, right? How many days is that for the length of one cycle? So Hussein's definition is spot on, but look at that cycle. We're going to put this on a graph, our own graph in a minute and see how this works out. What is the length of one cycle here, right? Sometimes it's the best way to do that, right? It's not 29 days, Kelvin. I'll tell you the best way to do it. look at the either two highs or two lows. That's one way to do it. And then subtract their corresponding x values from each other. So when I asked for the lows a few minutes ago, everybody told me the low was 0, right? So look at the corresponding x values that give you that low. One of those x values is 1. The other x value is 29. So remember how you get your cycle. You just subtract those two x values from each other, right? So I see 3 there as Lynette is thinking, no, Brendan is right and Hussein is right. You take the 29, which is one of the lows, and you subtract the 1, which is the other low from it, and that gives you the period. So the period in this case is 28, which means, excuse me, that the k value is equal, this is something we covered on one of those earlier videos, is 2 pi divided by 28, or pi over 14. Okay, that's the k value. Now, here's the way I'm going to teach you to write your function. We need to know what the phase shift is. And by the way, is everybody clear on that 28 days? Does 28 days make sense? Let me go back up and show you the numbers again. The first low occurred at 1 day. The next low occurred at 29 days. So how far is 1 from 29, where the two lows occur? Just subtract 1 from 29, which is how you get to 28. Is everybody clear on that? I just want to be clear. I want to make sure that everybody's okay with that. Okay, Davina says yes. How about you, Edmund? Is that clear to you as well? Edmund? Okay, somebody's hand is going up here. Yes, Lynette, go ahead, please. Sure. So one way to do it, if you didn't have the graph, if you have the graph makes it easier. Here is one. Let's go to graph first. Here's the first low. It occurs at 1. Here's the next low. It occurs at 29. So how far is 1 from 29? The distance, of course, between those two is 28. If we didn't even have, since our first x is not 0, it's because it's, that's right. The first x actually occurs at 1. Okay, Brendan? If it had been at 0, then yes, we could have used 0 minus whatever the other value is. Now, if you have a table, look at where the zeros are. The lows, I shouldn't say the zeros. The lows occur at 1 and 29. So we just simply take 1 from 29 to see how long it takes to complete that cycle, go from one low to another low. Does that help you out? Does that make sense? Okay, Lynette, great. Okay, so we have that as our k value for the period of 28. So 2 pi over 28 gives us the k value, pi over 14. The one more thing we need is the phase shift, right? What I call PS, or phase shift. Now, for cosine specifically, what I look for, and this is what the way I like to teach this, is where does the high occur? The high occurred 15 days into the cycle. That's where the high occurred. Now, normally the high occurs right at the start, but it took 15 days for us to get to that high. So because it's a cosine function, the high usually occurs at the very start. It took 15 to get to that. So we're going to make that PS 15 for a cosine function, specifically for a cosine function. So I'm now ready to write my my cosine function. And then we're going to use that cosine function to find our sine function. So here we go. So we're going to say that, let's use y and x. So y is equal to 50, right? That's your A. Cosine, open up a bracket, pi over 14, and then x minus 15, because that's your phase shift, plus 50, right? Because that was your C value on the end. Now, I'm going to get to Desmos shortly, right, for us to put all of this in Desmos. But the last thing I need us to do, or well, not the last thing, I have two more things to do here. The next thing I need us to do is to is to convert this into an equivalent sine function. Now, here's what we say. I find it much easier to write a cosine function first if I have the data. If I have the data and I can easily find where the high value is, I usually like to write the cosine function. Yes, Quinn, please go ahead. Okay, all right. So he wanted me to explain how to get the K value and Hussein that how I get the phase shift. So let me answer both of those questions. So Hussein, first of all, the phase shift for a cosine function. Let me remind you about something, Hussein. I'm just going to draw a cosine function, a very rough cosine function. Please don't, there's my cosine function. Now, my cosine function normally starts off at its high point on the y-axis, at 0 in other words. Right? Right, Hussein? Would you agree with me on that? Okay. But look at what happened to this function. The high point seems to have been shifted, or look at the table. The high point, which is 100, seems to have been shifted away from the 0 on the x-axis all the way over to 15. So it looks as if we've shifted. That's what the phase shift is. Look for how far the high has gone for a cosine function now. Look at how far the high has gone. The high has gone, the high on the y-axis is 100. And for us to get to that, we use 15. That's what I used a while ago for me to get that function, get that information. Okay, so there's our cosine function. 50 cosine pi over 14, sorry. That's not 4 at all, 14. X minus 15 plus 50. Okay, now, then there was Quinn's question about the K value. The K value, of course, is the number that you put inside of the first bracket. And to get that, if you have the period, Quinn, you always take 2 pi over that number. And of course, I reduce it down to get your K value. Okay, Quinn? All right, so it's always 2 pi over that number. And by the way, if you have the K value, you can also get the period by taking 2 pi over the period, and that gives you the K. So it actually works both ways. So the other thing that we should talk about is how do I write a corresponding sine function? I asked for a sine and a cosine. Well, this is my cosine function. So the thing I taught you a couple of days ago, right, was that I can make an equivalent sine function by taking a cosine function, adding a quarter of the period to it, and it turns into a sine function, if you can see what I'm pointing to here. So the first thing we need to figure out is, what's the period of the function we're dealing with right now? The period, remember, we said this before, was 28. So we're going to take that period of 28 divided by 4, which is 7, and we're going to take the current x minus 15 phase shift. And let me go back and show you what it says again. It says take the cosine function and add the period divided by 4. So this is x minus 15 now, plus that period divided by 4, which is 7. So really what I have now is x minus 8. Okay? So x minus 15 plus 7 is x minus 8. So I'm going to rewrite this function as a sine function now. Right? As a sine function. Everything else is going to be the same as it was before. So now y is equal to 50 sine. It's still pi over 14. That hasn't changed. What changes is the phase shift. So it's now x minus 8. But it's still plus 50. Okay? I'm going to give you 30 seconds to kind of absorb that. I'm going to stop sharing this screen and stop the recording. I'm going to go over to Desmos. I'd like you all to go over to Desmos. And I'm going to show you how you can put this information into Desmos and confirm that your numbers, your formula, your equation works. Okay? So I'll scroll up again just so that you can see what I did. Right? I first of all figure out all the pieces of the equation, right? What's the A? What's the number in the front? What's the amplitude? What is the vertical translation? What's the center line? So one is high minus low divided by 2. One is high plus low divided by 2. I have the period. Now, to get the period, if I can find two highs or two lows, I can subtract those two x values from each other. Not the y's, look for the x's. Then I would turn that into a k value. So 2 pi over that period gives us the k value. I look for my phase shift, and the phase shift is, where's the high for a cosine function? How far across did I have to go to get to that high? I had to go across the 15 to get to 100. That's my phase shift. So that would be x minus 15, etc., etc. So this is my cosine function. So then I want to write it as a sine function because I was asked to find both. I found the period, which I'd already figured out to be 28. Divide that by 4, which gives me 7. Take this phase shift of x minus 15 and add 7 to it, which gives me x minus 8. And here is my final answer. Okay, that's my final answer. Now, what I'm going to do is I'm going to stop recording then. All right, folks, you're all seeing my Desmos screen. You hopefully will remember the numbers that we had before. I'd like you all to follow what I'm about to do with the numbers that we had, which is open up. You should be able to see where I'm pointing to here. Open up the tab that says add an item. Everybody should be working with their Desmos right now. And go to table, right? All right, so everybody should be doing the same thing I'm doing. For that tab, for that table that you just opened up, we're going to put in the numbers that came from the table. So I'm going to be, let me just make sure I have my keyboard here, access to my keyboard. I'm going to be putting in the first number, which was 1. Now, Desmos is pretty smart. If I put in 2 next, it's going to say, oh, I'm going up by 1. So you'll notice that it's suggesting 3. And that makes sense because I'm going to go ahead. Actually, it's not that bad. No, that's not actually right. The next one is actually 4. So let me go back and put that in. All right, let me just delete all of these here. It wasn't going up by 1s at all. The next one was actually 4. The next one after that was actually 8. It doesn't go up by the same amount every time. Please copy these numbers into your Desmos table as well. 11, 15, 19, 22, 26, and 29. Okay, and then the y values, I put those in. I'm asking you to do the same thing. It was 0 first, then 10, then 50, then 80, then 100, 80, 50, 8, and 0. I'm just going to check my numbers here, make sure they're good. That's 1, 4, 8, 11, 15, 19, 22, 26, 29, and then 0, 10, 50, 80, 100, 80, 50, 0. Okay, now I'm going to minimize this here. Take a look at the numbers I just put in because those should be on a scatter plot right now, right? Which you should more or less be able to see. Right? Actually, what I'm going to do is I'm going to change my scale a bit on the x-axis. I don't need to see as much of the x-axis as I'm seeing right now. I'm going to make this maybe to -9 maybe. And the other side, I'll maybe go up to maybe 20. Okay. So that gives me a better feel for what I'm looking at. So there are the points, the same kind of points that you had before. Okay. And I'm going to put in my equation now. Hopefully you all remember the equation that we had before. We had 2 equations. We had a sine equation and a cosine equation. For you to put in the equation, go below into an empty box down here, right? And we're going to put in the y equals 50. I'm going to put in cosine. And it was pi over 14. Open up a second bracket. X minus 15. And then plus 50. Okay. All right. So is everybody okay with that? Now you'll notice that my graph, hopefully your graph as well, does a pretty good job of capturing the points. Does it capture every single point? No. Here is a point right here that kind of isn't right there, right? It's a little bit off of the charts. But all the other points are more or less there, more or less. So our model is fitting the data reasonably well. Let me just make sure everybody is able to do what I just did. I'm going to go ahead and while I'm waiting for you to put yours, and I'm going to put in my sine function as well. So y equals 50. Everything else is the same except for it's a sine function and the phase shift is different. So pi over 14 is now x minus 8, I believe it was, then still plus 50. Right? Now both of these should be overlapping each other because it's, as I said, just another representation, another trig function that behaves in the same way. One is written as a cosine, one is written as a sine, but they behave the same way. All right. Is there anybody who has not been able to draw these? Put the table in first of all, right? And get the points to line up with the equation that we put in. Is everybody doing okay with this so far? All right, Sinduja says yes. How about everybody else? Okay, use your equation to determine. So look at the table again. The table doesn't tell us what the illumination is on day 6. We went from day 4 to day 8. So we really don't know what it is for day 6, but we have a model that should help us to figure it out for day 6. How do we use a model to determine that? Can anybody help me out with that? Right? We have a model. We have an equation that's supposed to model how the moon's illumination is changing as the days pass. But it doesn't, when we collected the data, we didn't have anything for day 6. We collected on day 1, day 4, day 8, day 11. We don't have any information for day 6. Can the model help us to predict what it should be on day 6? Let me go back down and show you the equation that we have. Where does the 6 figure into our model? Do we put the 6 as the x or do we set it equal to the 6? Which one makes more sense to you? Right? Where do we put that 6? And how do we bring that into the model? Plug it in for x, exactly. That's exactly right. That's what we're going to do. So on day 6, the illumination is going to be equal to 50. We'll use the sine equation for no particular reason. Pi over 14, 6 minus 8, plus 50. Okay? All right, so I'm going to ask one of you to do that for me. Let me ask, let's see, Brannon. Brannon, can you grab your cat? Brannon, are you there? Brannon, can I get you to put all of those numbers together for us? And then we can look back at our graph and make sure that that calculation kind of lines up with the graph. Okay. We can kind of guess that the answer that we should be getting based on how this graph looks. The answer we're getting for day 6. 6 is somewhere around here. Should be somewhere in this region right here. Right? Somewhere around here. Maybe about 30% or thereabouts. But let's hear what Brannon says. Right? Brannon, let's hear your answer. And we're just waiting on, so 28.31. That sounds about right to me, right? Based on what the graph is saying, that would sound about right. 28.31, and that would be percent, by the way, because all the numbers that we are getting from the table, the y values are all percent values. Okay, 28.31 sounds about right. Now, is everybody else getting the same thing that Brandon got before we go any further? Chrisania says yes. Anybody else? Brendan? Okay, perfect. Okay, so I'm going to now go over to the next question that we have, which is not this, but that's this. Okay. The height, and this was a question from the problem set. I'm glad you brought that up a few minutes ago, Lynette. This is a problem set type of question, which I need you to be able to do. The height in meters relative to the surface of the water of a particular paddle on a wheel or a paddle boat is a function of time in seconds, as outlined in the data chart below. So as time is passing, when you're at 0, your paddle is minus 1.2, which means it's under the water. When you're at 5, it's a little deeper at minus 1.4. When you're at 10, Looks like it's starting to come up out of the water. 20 are at sea level. 25 you're above the sea level. It's rising, it's rising, it's rising, then it starts to fall again, and then it goes below the sea again, and it comes back up. So the height of this particular paddle relative to the surface of the water is at sometimes positive and sometimes negative. If it's positive, it means it's above the x-axis, sorry, above the water. If it's negative, it's below the water. So if you can imagine that thing turning on a wheel, and the wheel is and that particular point on the wheel is going to be going down below the water at some point and then coming above the water, and that's how this thing is turning. Okay, so really what we have is a circle like that, and there's a point on the circle, so there's water here. That's supposed to be water, and at some point it's going to be below the water, and it's going to be above the water as it turns inside of the water. Okay, so what we're about to do now is to come up with an equation based on what this looks like. So before we go to Desmos, right, we're going, sorry for being late. My Wi-Fi wasn't working, Hunayan says. All right, so that's Hunayan. Okay, so we're going to try to put together a reasonable equation like the last time. Then we'll test it out in Desmos afterwards. Does it work? And again, it may not be perfect. Our last graph was not perfect. There were some points that weren't quite there, but many of the points were. It was a pretty good model. So let's see if we can come up with a pretty good model here as well. So these are measurements that were taken. We went ahead and we measured at various increments of time at 0, at 5 seconds, at 10 seconds, at 15 seconds, and so on and so forth. And these are the various values that we measured as we went along. And so we're trying to come up with a model for this. Bear in mind that we said that this thing still holds. If I want a sine and a cosine function, I think it's easier to write a cosine function because then you can look to see where the high is and see how far along you have to get to that high. Then you can easily turn that into a sine function. So let's get to it. First of all, what is my A value? Think of all the things that we've been talking about, how to get that A value. Now remember, to get the A value, don't look at the X's. Don't look at the top numbers here. You look at the bottom numbers, the Y values. It's the Y coordinates that are going to tell you about the A value. So Brendan has jumped in and said it's the max minus the min divided by 2. Okay, give me the max, give me the min. Look at the table. You have the table in front of you. Find me the max, find me the min, and let's figure out what this thing is. I'll fold this thing back over again. All right, what's my max, what's my min for this thing? All right, so I'm getting 1.39 minus, okay, so you're minusing minus 1.4 though, Krisani, you know that, right? So 1.39, I agree, is my max, yeah. Minus negative 1.4. Can we agree on that, by the way? All right, good. That's what, oh, is there a minus there? Oh, I didn't notice that. Okay. All right, so it's 1.39 minus over 2. So what is that working out to be? Right, you all have your calculators there, right? What is that working out to be? So go ahead and do the math on that, work that out, and tell me what the A is. Everybody, do that for yourselves, please. So 1.39, essentially plus 1.4 divided by 2. What is that working out to be? Okay, that's going to be my A value. Come on, folks. I don't have to ask anybody in particular. 1.395, we'll use that. I want to be as accurate as possible. How about the C value? Yes, who is that now? Yes, Quinn, please go ahead. It's the highest value on the y-axis. Look at your heights. In this question, the heights represent the y values, okay? And the highest value that we can see is this one right here. And the lowest value is, let me see, 1 point, yeah, right, this one right here. So those are your two max and mins. Make sense? Okay, good. Okay, so I have 1.34, Hussein says. I don't know. I thought it was 1. I thought 1.395. Are you asking a question about wrong calculation? Yeah, I think that might be a little bit off. Let's get to the C value. Now, the C value is a vertical translation. How high up are we? Now, do you remember how to get that? We did that the last time. Anybody remember how to get that number, right? What is that number that we have for the C value, the max plus the min divided by 2? We have the max and the min already. So it's the 1.39 plus the minus 1.4 max plus min divided by 2. So can you tell me what that is, please? Anybody? Quickly. What is that value? And don't round it, just give it to me exactly as it comes out. I've done this question before, so I kind of have an idea what it's supposed to be. What is that? Do this for yourself, folks. Don't wait for somebody else. No, don't just wait for Brenda. Okay, Roma. Thank you, Brenda. Thank you, Roma. So it's a minus 0.005. Minus 0.005. Perfect. Okay. Now, the period. Sometimes that's the most difficult thing to get. The period, remember, if you can find two highs, then that can help you out. If you can find two lows, that can help you out as well. If you don't have that, here's another option, right? So we don't have two highs here because we only have 1.4, minus 1.4. Sorry, 1.39 is the high, and we have one low at minus 1.4. Sometimes take the high and the low and consider that to be half of the period. Let me say that again. Take the high and the low, right? The high is at 5, occurs at 5. So here's where the high occurred. Sorry, at 35 is where the high occurred. Here's where the low occurred, right? At 5. The difference between those two would be half of the period, right? So if you go from a high to a low, that's half the period. So if I'm going from 5 to 35, that's 30 minutes. Is this minutes? Is this minutes? Is this minutes? Seconds, sorry. So it's 30 seconds that gets from the high to the low. So twice that would be the period. So that means that in this case, I can consider the period to be 60 seconds. So that's another way that we can get what the period is. So here's my K value then. My K value is 2 pi divided by 60, which is pi over 30. Have I lost anybody so far? Is everybody with me so far? All right, hopefully that makes sense. All right, stop me if you're not so clear. And in this case, it's kind of suggested from the table going from 0 to 60. It is going from minus 1.2 to minus 1.2, but the truth is that those are not the two lows. So we have to be very careful that we're not assuming that that would be a full period. But a good way is to look at the low and the high and find the distance between the low and the high, and that would be half of a period. Okay, so the only other thing we now need is the phase shift, the PS. Remember what I said the last time is for a cosine function, and I'm going to recommend that you start off with a cosine function, look to see how far you had to go for the high. Can anybody answer that question? How far along did we have to go along this cycle to get to the high of this function? Quinn and everybody else is saying 35 seconds. Well done. So 35 seconds. So what I'm going to do is I'm going to write my function now. My function is going to be that the height, and use the variables that they use, the height is equal to the 1.395 times the cosine of pi over 30 x minus 35 plus, minus 0.005. Oh, come on. Minus 0.005. No, seconds. Yes, Brandon and Quinn, you're both right. No, I want to write this as a sine function as well. Now, remember, I need to find a quarter of the period. The period we said was 60 seconds. I'm going to take that 60 seconds and divide it by 4. So for me, that's 15. I'm going to take my x minus 35. I'm going to, remember, cosine to sine. It's right here. Cosine to give me sine, I add a quarter of the period. I'm going to add on to that the 15 seconds. So here's my new phase shift. x minus 20. That's my new phase shift. So here comes my sine function. Everything else is the same. So it's still 1.395, same as before. Now it's sine, it's still pi over 30, but now it's going to be x minus 20 plus, I keep putting plus, it's not plus, minus 0.005. Okay. I'm going to stop sharing this. We're going to go over to Desmos and we're going to see if this matches up nicely or not, right? Do all of these points fall very neatly onto our graph? Are they all there, or are some of them a little bit off? If some of them are a little bit off, that's fine, right? That's no big deal. So I'm going to stop sharing this. I'm going to go across to Desmos. I'm going to start sharing my Desmos screen with you. And then we're going to excuse me, put these points in, and we're going to put the equations in and see if everything matches up nicely. Okay? So let's first of all put our table of values in. Now you're going to need that table of values, so that's going to be a bit of a challenge. So you just have to follow I have the table still on another screen. So you're just going to have to follow my lead on the table of values, right? I'll put the table of values in for you, and you just simply enter the same values that I'm entering because you don't have them in front of you now. But remember, you have to go up to the table under the plus sign, and then when the table comes up, you start putting in your x and y values. Now we're lucky this time that the values actually go up by the same amount every single time. So when I put that 0 in for the first one, and then I put in 5 for the next one, Desmos is going to take over and say, oh, we're going up by 5. So it's just going to keep going up by 5 until we get to 60. 60. Here we go. The y values, those have to go in manually. Okay, so just follow my y values here. So minus 1.2, minus 1.4. I can't see the text right now as I'm just copying the figures from my other screen. Minus 1.31. So I'll take any questions after this. Hold on, where did I get those numbers from? Ooh, sorry, minus 1.2, minus 1.4, minus 1.21. That's wrong. Sorry, folks. 15 is minus 0.7. And 0, so right at sea level. And 0.68. 1.19. 1.39. 1.21. You should all be putting this in at the same time as I'm doing this. 0.71. Minus 0.01. Minus 0.69. And minus 1.2. Okay, so hopefully everybody's following along with all of those points. All right. And I'm going to go down now and I'm going to put in the equation that we just got on a new line. So click on a line that's below the one that you had, and your y equals, I'm going on memory now, 1.395. Then it was, let's put the cosine one in first. Cosine pi over 30. It was x minus 35, I believe. It was 35. And then that would have been plus, oh, sorry, minus 0.005. Okay. I'm going to make sure I can see what's going on in the chat room here. Okay, good. All right. So let's just see if these line up nicely. I'm going to hide the expression list. I'll put in the sine equation in a little while. Let's just zoom out some. Now, it looks to me like we're lining up pretty nicely. I'm going to squish down the y-axis. And I think it was Edmund who was asking about how we change the scale. I don't need to go up as high on the y-axis as this goes. So what I'm going to do is, and I need to go a little bit further along the x-axis. I'm going to come in here on the little wrench thing. And I'm going to say on the y-axis, how about if I just go up to maybe, or go down. Let's go down first. Down to maybe -5, or maybe -4. And on the other side of that, maybe I'll just go up to +4. Right? I maybe don't even need to go that high because it only has to go up to 1.4. But that's really your call. And then on my y-axis, on my x-axis, I want to at least get to 65. So I'll change this to maybe 70. Okay. Now look at my graph, and hopefully yours is similar. I'd say that match is pretty darn good, right? I'd say that there's almost no point that has fallen off of that grid whatsoever. Our model is working. Our model is working really, really well. Now, let me go in and put in, I see that we're almost running out of time here. I may have to take this into tomorrow's class as well. Let's go in and put in the sine function as well. So y equals 1.395, and then I over 30. I need to put in what it is. It's a sine function. I over 30. No, it's x minus, I think it was 20. And then minus 0.05. 0.005 actually. And as you can see, both of them seem to line up really, really nicely. You can't tell that there are two lines there. Now, the other thing that we need to be able to do is answer questions with the model. And I know we are running up against the clock, right? But let's at least look at one of those questions. I'm going to stop sharing this, the equation, okay? All right, so let's go back to this very, very quickly. Very, very quickly here. So here's our equation. Now look at one of these questions and let me hear what you think. We'll skip the diameter of the wheel thing here. C, I think, is the easy part. What would the height of the paddle be after 97 seconds? Right? I think that's pretty obvious. Just put the 97 into the equation and get our answer. But how about this? After how many seconds will the paddle reach a height of 1 meter above the surface? How would we answer that? And I'll leave it there and then we'll finish this up tomorrow. And I didn't realize that this would take as much time. I think me having to go back and forth is what really takes up a lot of the time. But anyway, how would we figure out how many seconds it would take to reach to a height of 1 meter? Can anybody suggest something very quickly? Set the y equal to 1. No, at that point, we'd have to solve an equation. So I'm actually going to, it's now almost the end of the class. So start looking at the homework question. I'm not expecting that you would necessarily, actually, I think you should be able to do it, but start looking at that homework question that I put in there. It's just a one question thing where you're supposed to use Desmos to, well, first of all, figure out the equation on the line from the table, and then use Desmos to match it up and make sure it works. So try that on your own, see how that works, and then tomorrow we'll talk about this some more. Folks, I see you all in block 4. So I'm sorry I have to sort of rush through like that, but we got to leave it there and come back in block 4. See you later. Bye, folks. Bye for now, anyway.